I love algebra. Today's a good day because today you get to do a lot of algebra, okay? All right, so 3-5 is actually pretty easy. It's 3-6 where it gets a little bit harder. 3-5 is just going to talk about slopes. And then the reason we're doing this, why are we all of a sudden learning Algebra 1 today? Because we're going to connect what we've learned about parallel and perpendicular lines in geometry to what you should have learned about parallel and perpendicular lines in algebra. And we're going to write equations of those parallel lines and equations of those perpendicular lines. So we're going to talk about all the different algebraic things you learned, okay? So starting with slope, which is rise over run. The slope you should have learned is basically a number that describes how steep your line is. So it gives you the steepness of a line. And I'm going to go pretty quick, but stop me. If I'm going too fast, you're like, whoa, I don't understand what you're saying. Please speak up and slow me down, okay? Rise, we already said in the review there, was the difference in the y values. And so when we look at the slope formula, which is rise over run, slope formula is down here. You'll notice that the difference in the y's is on the top. y2 minus y1. Run is going to be the difference in the x values. Sorry, 1 second. So difference in the x values. And then notice in your slope formula down here that that's x2 minus x1 on the bottom because it's rise over run. The ratio of the rise to the run. And I'm assuming you guys have seen the slope formula, y2 minus y1 over x2 minus x1, correct? Okay, so when we're working our problems and we're just trying to calculate slope, slope is just the number that goes in front of the x. It's just a number. No x included, just a number. If it's graphing and you have to graph it, I am totally fine if you just count the rise and count the run. Just be really careful. If you go down, what does that do to your number? Makes it negative. And if you go left, makes it negative. And if you have a negative over a negative, that is the same as a positive, okay? So just be careful that if you are just counting your rise and counting your run, that you're including the direction in that to make it either positive or negative. Also with slope, do not leave them if they can reduce. So if you have 6 over 4, I expect you to reduce that to 3 over 2, okay? So don't leave it 6/4, change it to 3/2. But do not write your slopes as mixed numbers. You wouldn't want to say 1.5 because that doesn't help you figure out what is my rise, what is my run. So leave them improper like 3/2, which I'm assuming you guys did in Algebra 1. Is that correct? Okay, awesome. All right, so again, if it's on a graph, feel free to just count. If it's not on a graph, then you can use your slope formula. Biggest mistake I usually see with students is they do it the other way. They do x on top and y on bottom. Be careful, it is rise, which is y, over run, which is x. So be really careful about that. All right, so first example, use the slope formula to determine the slope of each line. I will tell you again, if it is on a graph, you don't have to use the slope formula. You can just count rise over run, and I'm fine with that. But AB is a special kind of line. What is AB? What kind of line is AB? Okay, it's straight. Every line's technically straight, though. What kind of line do you mean when you say straight? Look at AB. What kind of line is AB here? Okay, it doesn't cross the x-axis, but what do we call lines that look like this? Horizontal, right? It's a horizontal line. What kind of line is a line that looks like this? Vertical. Okay, horizontal lines and vertical lines have special characteristics. What is the slope of every horizontal line? Who said that? Good, 0. Every horizontal line is going to have a 0 slope. Write that down somewhere so you'll have that in your notes. Horizontal lines always have a 0 slope. There is no work to do. You should be able to look at it and go, oh, it's horizontal, my slope is 0. Okay, let's talk about the other one, vertical lines. Vertical lines do not have a 0 slope, but they do have a special slope. What is the slope of every vertical line? It's not 1. If it was 1, that would mean it would be rising 1, running 1, rising 1, running 1, so it would still be diagonal. Okay, 0 over 1 would be horizontal. So for example, let's look at this horizontal line. real quick and let's calculate its slope. So when I go from point A to point B, how far am I rising? 0. So that's why we get 0 over. How far are we running from point A to B? Count it. How far is it from A to B? 5. But what is 0 divided by a number? 0. Okay, I will warn you, I will not accept 0 over 5 as an answer. You have to go the step further to tell me that 0 divided by a number is 0, and the answer is just 0. Okay, so for the slope of AB, our answer is 0. But look at the vertical line AD. So now I'm going to shift to AD. So what is our rise from A to D? Okay, and we're going 6 what direction? Down. So the slope would be -6 over, how far do we run from A to B? Careful, from A to D, not A to B. I think I said A to B. A to D, how far do we run? 0, right? We're not going left or right at all. What did you learn way back in elementary, middle school about dividing by 0? You can't. And what do we say it is if you divide by 0? It's not 0. That would be taking 0 and dividing it by a number. Okay, but there's a word we use. A solution would be if we had an equation and we were trying to solve for it. So we don't technically say no solution. It starts with a U. UN. Undefined. The slope is undefined. When you talked about dividing by 0, you should have been told it's not possible. You can't divide by 0. It is undefined. If you take your calculator and you type in -6 divided by 0, it's going to say error. If you type in your calculator 0 divided by 5, it's going to say 0. So I will not accept 0 over 5, and I will not accept -6 over 0 because I want to know, do you know which one is actually 0 and which one is actually undefined? So you have to go a step further. Every horizontal line will be 0 slope. Every vertical line will have an undefined slope. So every vertical line you will put undefined. Chris, did you have a question? Everybody with me? All right. And if you're not sure, if you forget, use your calculator. If it's undefined, it's going to say error. If it's not undefined, it's going to say 0. So it'll tell you if you type it in which one is 0 and which one is undefined. You just need to remember the word undefined. Any questions there on finding slope? Okay, so we'll move on to some other examples. We already talked about this. It's impossible to divide by 0, and that makes it undefined. That's also in your notes there. So flip your notes over. All right, so here's one that says use the slope formula to determine the slope. We're trying to find the slope. It does say use the slope formula. In this case, since it's not graphed for us, I would tell you we want to use our slope formula. You could graph it and count the rise over the run, but since we don't have a graph, I'm not passing out graph paper right now, let's go ahead and just use our slope formula to practice. Does it matter which one of these points we call x1, y1? No, you pick. It doesn't matter. Pick one of them to be x1 and y1. Pick the other one to be x2, y2. Does not matter. But whichever one has x1 in it, it also has y1 in it. All right, then plug it into your slope formula. I'm going to write it down. The more you write it, the more you'll memorize it if you have forgotten it. So write it down. It is the change in y over the change in x. The difference in the y's over the difference in the x's. So if we're using these coordinates up here on the board, what would we plug in for the top of our fraction? Oh, I'm sorry. Thank you, Chris. I wrote that down wrong. That should be x2 minus x1, not x2 minus x2. Thank you, Chris. Okay, sorry. On the top, what would we have? -1 minus 1. So remember, there's a minus in the formula, and then you do y2 minus y1 over, what's going to go in the denominator? 2 minus 3. Good. Now simplify. What is -1 minus 1? -2. Be careful. Like signs, you add. What is 2 minus 3? -1. And negative 2 divided by negative 1 becomes a positive what? 2. Okay, so the slope would just be 2. Now, I will tell you, use your calculators to check. You are fortunate. You get a calculator in here. My pre-AP kids do not get a calculator. So use it to your advantage. Do the math mentally in your head. Practice that, because when you get to Algebra 2, they're going to take the calculator away from you part of the time, because you've got to do some skills in Algebra 2 without a calculator. But practice it mentally, then use your resource and check it. Make sure that you did it correctly, okay? You don't want to miss a problem just because you added when you should have subtracted or something like that. So always check your answer there. Questions on using slope formula? All right, I'm hoping that this will all be pretty easy here. Okay, so the next thing we've already talked about zero slope for horizontal lines. We've already talked about undefined slopes for vertical lines. And then if the line goes up from left to right, it's going to have a positive slope. If it's going down from left to right, it's going to have a negative slope, right? We learned all of that in Algebra 1 as well. And then the other thing that they're going to remind you about here is that slope also means, in terms of word problems, the rate of change. So in a word problem, if you see something like miles per hour, that is your slope. That is the rate at which it's changing. We don't just learn slope to graph a line and say, what's its rise over its run? There's a real life application to slope, and slope is the rate at which something is changing. And so anytime you have a rate of change, that is your slope. Okay? So then we have a word problem where we're going to apply that idea of slope. So Justin is driving from home to his college dorm. At 4 o'clock, he is 260 miles away from home. At 7 o'clock, he's 455 miles from home. It says graph the line that represents Justin's distance from home at a given time. Okay, I'm going to stop right there. I know I gave you a graph on your notes, but on the homework, if I asked you to draw a graph, would you know on your graph paper which axis to put time and which axis to put distance? And I'm asking you, do you know which one should be X, which one should be Y? So what do you think, Chris? Okay, so the way you determine which one should be which in Algebra 1 is you should have talked about how X is the independent variable and Y is the dependent variable. Did you guys talk about that in Algebra 1? So which one depends on the other? Does the time depend on the distance, or does distance depend on time? Which one's going to occur no matter what? Time. Time is independent of anything else. So independent should go on your x-axis. So that means the time should go on the x. And what is our time being measured in? Hours. And then that means the distance should go on the y. And what is the distance being measured in? Miles. So when you do a graph for me, whether or not you were told to do this in Algebra 1 or not, I expect you, if it's a word problem, to label your axes with what they represent. Okay, that's a good thing, good habit to get into. So label your x-axis, label your y-axis, and before you leave today, you will need graph paper. So make sure you have graph paper in your binder. If you don't, at the back of the room, in the tray back there is graph paper. Grab some paper, stick it in your binder. Okay, because you will have to graph some things on your homework. All right, so if they asked you to graph, label your distance, label your time on your axes. Nathan? Yes, if you have your own graph paper, that's fine as well. Just don't draw your own graph by hand. I want you to use graph paper. Okay, so then they give us some information. At 4 o'clock, he's 260 miles from home. At 7 o'clock, he's 455 miles from home. So that means our x-axis has to go how far in terms of time? What's the latest time we have here? 7, right? So we at least need to divide this so that we can get to 7. So if we start here at 0, we could go just graphing the afternoon if we want to. This would be 1, 2, 3, 4, 5, 6, 7. So make sure you can space out your time. So here's 7, here's 4. And then the distance, how high do we have to get for distance? 455. So what would be a good unit for us to go by on our y-axis then? We could go by hundreds. If you think about the actual graph paper, we could probably even go by something smaller. 50s might be fine to get us to 455. Just try to spread your graph out. Don't cram it all down in one little bitty section on your graph, okay? Again, I know I gave you a picture of one and they've already spaced it for you, but I want to make sure you could do it if you had to. So you might want to go by 50s. That would be 50, 100, 52, 53, 54, 55. And so we could go all the way up to there to get to 500. And then you could spread that graph out and plot your points. You could plot your point for 4 to 60. This was 1, 200, 300. So we would be at 4 to 60-ish. And then 7 at 455, which would be a little past 450. And then draw your line. And when you draw your line, make sure and include your arrow. Technically, it's going to stop here because you can't have a negative time. So it wouldn't go on past here, right? Are you guys with me? Okay. Again, it's on your paper, your graph, but I want to make sure everybody would be able to graph if I asked you to. Any questions on how to create a graph? Okay. Then it says to do what? Once you graph it, do what? Find the slope and do what with that? Interpret it. So we're going to have to write a sentence about what does it mean according to this problem. So let's find our slope. Again, you could use rise over run, but I think it will be harder here because we're going by different units. So it's going to make it a lot tougher to count the rise and the run because we're not going by ones on our y-axis. So instead, I would suggest you use your slope formula, y2 minus y1 over x2 minus x1. What are our 2 points that we graphed here? What are these coordinates? Good. Okay, so the first one is at 4 o'clock. He's 260 miles from home. The second one is at 7 o'clock. He's 455 miles from home. So those are our 2 coordinates. So let's plug them in. Naomi, tell me what would go on the top. Very good. And let's go with Faith. Tell me what would go on the bottom then. Be careful, since she started with 455 minus 260, you have to go back and start with 7 minus 4. Good. Now, if you had chose to do 260 first, then you could have chose to start with 4. Okay, let's simplify. What's 455 minus 260? 195. What's 7 minus 4? 3. What's 195 divided by 3? 65. So it said find the slope. The slope is 65. And then it said interpret the slope. So what does that mean, 65, in relation to this problem? So what would we say about this? Like, how could we write a sentence explaining what does 65 mean in reference to what Justin's doing? Carlos? Exactly. So remember, this was miles that we were plugging in for y, and these were hours that we were plugging in for x, right? Which means 65 is miles per hour, which means Justin is driving at a rate of 65 miles per hour. So we would write that as a sentence. Justin is driving 65 miles per hour. Now, he may not be driving consistently 65 miles per hour, but that is what his average rate of change is over that period of time. Any questions? Okay. Say it again. Well, he's obviously going to college far away from home, right? Yeah. So he's going far away, at least farther than the U of A. All right. So if you look at the next chart you're going to see in your notes. Now, I don't know how much of this you learned in Algebra 1. You guys tell me. This is the connection to geometry that we're learning today, though. We've been talking about parallel lines and perpendicular lines. So parallel lines, we already know in geometry means they never intersect. They're coplanar, they don't intersect. Algebraically, on a graph, that means that they will have the same slope. Did you guys learn that parallel lines have the same slope in Algebra 1? Okay, if they're never going to intersect, they have to be rising and running at the same rate. Otherwise, if they don't have the same slope, eventually they're going to intersect. So if they have the same slope, they are parallel. Here's my question for you. Can parallel lines have the same y-intercept? No. If they had the same slope and the same y-intercept, what would that mean about them? They'd be the same line, right? They would be right on top of each other. We call that something different, and we're going to talk about that in 3-6. So if they have the same slope, but different y-intercepts, and so you can make yourself a little note here if you want to, that they will have different y-intercepts. Okay? They will have the same slope, but different y-intercepts to be parallel. All right, do you know what's true about perpendicular lines? And it's not written down here on this chart the way that you might have learned it in Algebra 1. Did you learn anything about perpendicular lines and their slopes in Algebra 1? If they're perpendicular, what do you think would have to be true about their slopes? Okay, opposite meaning what, Jackson? Okay, if one is positive, the other one would be negative. Does everybody agree with that? Okay, so they're going to have opposite slopes, but more specifically than just opposite, do you know what happens to the actual numbers of the slope? So for example, if one line had a slope of 2/3, the other perpendicular line, Jackson's right, would have to be negative, but it wouldn't have the same numbers. They would be the reciprocal of each other, 3/2. Did you guys learn in Algebra 1 that perpendicular lines have opposite reciprocal slopes? Okay, then that's new for geometry today. So that is listed differently here, but if you flip over, this is how most textbooks and most teachers teach it, that perpendicular lines are going to have opposite reciprocal slopes. And that's probably the easier way to think about it. They have opposite reciprocal slopes. So if one of them has a slope of A over B, because it's positive, the other one is going to have a slope of negative, and then you're going to flip it, B over A. So if one is 2/3, the other one will be -3/2. The one that is always tricky for students, and I don't really know why, but it's just because the number messes you up. What if my slope is 1? What's the perpendicular slope? It would definitely be negative. I heard negative, right? Because if this one's positive, then this one's negative. What is 1 as a fraction? 1/1. So if you flip it, what does it become? Just -1, right? -1/1. So if you have a slope of 1, the opposite reciprocal is just -1, because when you flip it, it stays the same number. Does that make sense? Okay, what about if I have a slope of -2? What's the perpendicular slope? Who said 1/2? Very good, Michelle. It needs to change from negative to positive. And then what is 2 as a fraction? 2/1. So the perpendicular slope has to have the reciprocal slope. So if I flip 2/1, what does it become? 1/2. So it's going to have the opposite sign and the reciprocal fraction. Does that make sense? So ask yourself every time, if it's negative, I have to change the sign, and then how do I flip it? What do I get when I flip the slope? Okay, so perpendicular lines are going to have opposite reciprocal slopes. The next thing they're going to ask you to do then is to take some points and graph them. I went ahead and gave you the graph to save time this morning, but I expect that you can take these coordinates and put them on a piece of graph paper. In Algebra 1, we should have all learned how to plot points, right? The one thing I would warn you about, every year I see students, they get to their homework and they see the points and they graph all 4 of them at once, and then they connect the wrong letters. So be very careful. It says to graph each pair of lines, use their slopes to determine whether they are parallel, perpendicular, or neither. The lines are UV and XY. So when you graph the points, make sure you connect U to V and then connect X to Y. Does that make sense? Just be really careful, otherwise you'll be connecting the wrong lines. And what I'll usually see is somebody will do y to v and u to x, and then that messes everything up. Okay, once you graph it, don't assume, oh, they look perpendicular, they must be perpendicular. You can have an 89.9 degree angle and it is not perpendicular. So be careful. You're not going to base your decision on how the graph looks. You're going to base your decision off of your slopes. If they have the same slope, they're parallel. If they have opposite reciprocal slopes, they're perpendicular. And if they don't have either one of those, then it's neither. And here's where they get tricky on you. Are those two lines perpendicular? I heard no. Does everybody agree that it's no? Do they have opposite slopes? They do have opposite slopes. One's negative, one's positive, but do they have reciprocal slopes? No. They do not have opposite reciprocal slopes, so they're not perpendicular. What about this one? Are these two perpendicular? Nope, I saw a few yeses there. Do they have opposite slopes? No, they have reciprocal slopes. They're flipped, but they're both negative. To be perpendicular, they have to be opposite and reciprocal. So be super careful. All right, so let's find some slopes here. Do you guys want to do these by counting rise over run or using the slope formula? You want to do slope formula, not rise over run? Okay, so let's do slope of UV. So we're going to use the point U, and we're going to use the point V. If you prefer to do rise over run, count it on the graph and see if you get the same thing. So the slope of UV, what's going to go on the top, Jackson? Careful, that's an X. Slope is rise over run. Good. It's 2 minus a negative, but minus a negative is a positive. So 2 minus negative 1 becomes 2 plus 1. What's going to go on the bottom, Sydney? Okay, it wouldn't just be 0 and negative 1. Very good. 0 minus negative 1. And what's that going to mean since it's minus a negative? Add. Good. Plus. So what is 2 plus 1 on the top? 3, and 0 plus 1 on the bottom? 1, and 3 over 1 is just 3. Okay? Now we need to find the slope of xy. Do you want to do it by the slope formula again, or do you want to do it by counting rise over run? Okay, so let's practice rise over run. So I'm going from x to y, right? So from x to y. So how far do I rise? Okay, and am I going up or down? Up 2, so that's a positive 2. And then how far do I run? Okay, and is it 6 left or right? Left, so what does that make it? Negative 6. Okay, reduce that. What is 2 over negative 6? Okay, 1 over negative 3. So now compare your two slopes. Is one positive and one negative? Yes. Are they reciprocals of each other? 3 over 1, when I flip it, is 1 over 3. So yes, they are. So they are opposite reciprocals, which makes them perpendicular. Any questions? All right, again, if they had the same slope, they would be parallel. Otherwise, if they don't have the same slope or opposite reciprocal, the answer is neither. I'm sorry, say it again. You can just put the perpendicular symbol, or you can write the word perpendicular, or you could technically say UV is perpendicular to XY, but you don't have to do all of that. You can just tell me perpendicular. Okay, and you can always just use the symbol if you want to. All right, let's look at 3-6. 3-6 is where we get into all the equations. So now we're trying to write equations of lines. We're going to graph lines as well in this section. We have our two forms, point slope and slope intercept. And you have to know the difference between the two. I'm going to be super picky about that. If the directions say write it in slope-intercept and you write it in point-slope form, you will not get any credit. You have to know the difference. So point-slope is where you're given a point, and it's just any point that's on your line, not specifically an x-intercept or specifically a y-intercept. It's any point, and you're given the slope. So a point and the slope. Point-slope formula, y minus y1 equals m times x minus x1. Okay, m is the slope, and then you have a point x1, y1 that you're going to plug in as a number. Your black letter y and your black letter x should always stay y and x. They're not going to turn into numbers in your final answer. So you'll have equations that look like this. Okay, biggest mistake I see with point slope form is students picking out the point incorrectly. Notice the formula has minuses in it. That means when you pick out the point, it should be x, and this is wrong. This is a typo. Please fix this in your notes. Scratch that out. That is not supposed to be 3, 4. Your point should be x comma y. Your formula was m times x minus x1. So what is x1 according to this part right here? What is x1? 4. So that should be 4 comma. Notice it has a negative, but it's not negative 4. The negative is from the formula. The 4 is the x1. And then come over here. This is y minus y1. So what is our y1? 3. So when you pick out your point, you're going to change the signs because the formula has minuses in it. Okay? And then your slope is just the number in front, 2. All right. Slope-intercept form is y equals mx plus b. M we already know is the slope. What does B stand for? The y-intercept. On the y-axis where the line crosses the y-intercept. So then we have y equals, for example, 3x plus 6. The slope is 3. The y-intercept is 6. Okay, the next two parts are the parts I often see students struggle with. Just like we talked about slope. If it's horizontal, the slope is 0. If it's vertical, the slope is undefined. Those two lines have special circumstances, so they do not fit the mold for point slope or slope intercept. It's different. If it is a vertical line, the equation will always be x equals a number. Because vertical lines have an undefined slope, so it's not going to fit y equals mx plus b or this point slope form. It's x equals a number, and that number is where it crosses the x-axis. It's the x-intercept. Okay, so for example, a vertical line might look like x equals 5. Horizontal lines, they have a 0 slope, so again, they don't fit the mold for these. They have a 0 slope. It's going to be y equals a number, and that number is always going to be the y-intercept. Where is it crossing the y-axis? For example, y equals 2. Okay, so really quickly, I'm going to put up a couple pictures here on the board. You guys give me the equations for them. What's the equation for that line? An equation is never undefined. That's a slope. An equation has to either be x equals if it is vertical or y equals if it is horizontal, and it is a number. So if this is this line here, what would my equation be? X equals 2. It's vertical. The y is constantly changing, but what is not ever changing? The x value. That's why it's x equals 2. Okay, let me give you another one. What would be the equation for this line? Should be y equals 3. Again, it's horizontal, so it's y equals. If you forget which one's x equals and which one's y equals, then just ask yourself, what never changes? The x value is constantly changing, but the value that never changes here is the y value of 3. So it's y equals 3. Okay? All right. Oops. X-intercepts and y-intercepts. This is very important for this lesson. An x-intercept and a y-intercept have specific coordinates. If it's a y-intercept, that's where it's crossing the y-axis, right? So its coordinates should be 0, comma, and then the y value. An x-intercept is where it's crossing the x-axis. So its coordinate's going to be a number, comma, 0. Okay, we should have learned that in Algebra 1. So now we're going to get to where we have to actually write some equations of lines. The first one here is super simple, but again, I would point out you have to know which form to use. So what form does this tell us to use? Point slope form. So the first thing you're going to do is find out what form do I have to write it in. If it doesn't tell you, you get to choose. But if it tells you, you have to do it in the form they tell you to use. Point slope form. What is point slope form? Very good. Okay, you have to memorize it. You have to know that. All right, so the only things we need to know to write this equation are what? What things do we need to plug in and have for a number? Okay, before I actually look at the problem here, in just this equation, what things do I need to replace? Okay, y1, x1, and the slope. So we should have numbers everywhere I have a blue letter. All right, so now let's go to the problem. What do they tell me first? Slope is 6. So where's 6 going to go? M. Okay, then what else do they tell us? Okay, so they tell us that this line passes through the point 3, negative 4. So they're giving us an x1 and a y1 that is on the line. So what's going to go in for y1? Negative 4. So when we write this, it's actually going to turn out to be, Chris said, y plus 4, because we're going to change the sign when we plug it in. We're going to change the sign when we pick it out. Minus a negative is a positive. Y plus 4 equals 6 times. What are we going to have in parentheses? X minus 3. And that as far as you go. Do not distribute the 6. Do not subtract the 4. You are not trying to write this in slope-intercept form. This is your answer. As simple as that. Just plug it in, stop. Point slope form. Okay? Let's try another one. What form does this one tell us to write it in? Slope-intercept form. So what is slope-intercept form? It's not point slope form, so it's the other one. What's the other one? Y equals mx plus b. So what do we need to replace with letters in this formula? What letters get replaced? What letters do we want numbers for? M and X is not going to have a number in our final answer. B. You should always have a Y and an X in your final equation. You should have a number for your slope and a number for your y-intercept. Okay? So for our final answer, this is what we should have, a number in the red spots. Okay. What do they give us here, though? They give us 2 points, right? 2 points on our line. So there's a couple of options. One, you could take a piece of graph paper. You could graph those 2 points. And then what would you need to find about that line? The slope. So you would need to count the rise over the run. Or if you don't want to graph it, what could we use to find our slope? Exactly. We could just use our slope formula. y2 minus y1 over x2 minus x1. And Chris, you said it the other way around, which is totally fine. Does not matter. You can do y1 minus y2 over x1 minus x2. Does not matter. All right, so let's plug it in. What's going to go in on the top? Two minus 0. Make sure you're doing y minus y over 1 plus 1, because it's going to be 1 minus a negative, which is a plus, right? And that gives us 2 over 2, which reduces to 1. Okay, so the first thing we know is our slope is 1, so we're going to plug that in a few minutes. And then we need to find the y-intercept. The worst way to plan to find the y-intercept would be to graph it and try to figure out where does the line cross the y-axis. because that will only work if you have a nice, pretty whole number for your y-intercept. If your y-intercept turns out to be a fraction, you cannot find it graphically. So I'm not going to go over graphically because it's the worst way. I want to do what's going to work every time. But if you get confused and it's on the test and it does turn out to be a nice, pretty whole number, you could graph the 2 points and then just keep doing your slope of up one, right one, up one, right one, down one, left one, down one, left one, until you find out where it crosses the y-axis. Best way, though, is not to do that. So does anybody have any idea how we can find our y-intercept? Okay, I'm going to tell you. So once you find your slope, you can plug your slope in. So make a note on your paper. Plug in slope, and then plug in a point. You pick between the two that are given. Plug in one of your points. And then you're going to solve for b. Those are the steps to find your y-intercept if you don't use a graph. Plug in the slope, plug in one of your points for x and y, and then solve for b. So we're going to use this equation we have here, y equals mx plus b. We're going to plug in our slope, which we found to be 1. And then which point do you guys want to use, -1, 0 or 1, 2? 1, 2. So then we're going to take this point and we're going to plug the 2 in for y and the 1 in for x so that we can solve for b. So we'll have 2 going in for y, 1 going in for x. We already plugged 1 in for the slope, which we found over here. And now we're going to solve for b. So what do we get when we do 1 times 1? 1. So we have 1 plus b equals 2. And now what do we do to solve for b? Subtract 1. And what is b? 1. And then you're going to go back and write your equation. Your equation should always still have a y and an x in it. So when you write your equation, the only 2 numbers you're trying to plug in are the slope and the y-intercept. So what will our equation actually look like? Very good. Y equals 1x plus 1. 1 for the slope, 1 for the y-intercept. Technically, do we need this 1 in front of the x? No, you could have just wrote y equals x plus 1 because there's an implied number 1 in front of your variable if there's not a number written there. Questions? All right, let's look at one more. The next one looks a little different, and I want to make sure we go over this one because I often see mistakes on this one as well. First of all, what form does it want it in? Point slope. What's point slope again? Y minus y1 equals, okay, m times x minus x1. Write it down. Say it. The more you write it, the more you say it, the more you're going to memorize it. Okay, again, what do we need numbers plugged in for here? y1, m, and x1, right? We should still have a y and an x in our final answer. Okay, what are they giving me here? X-intercept and y-intercept. The most common mistake I see is students telling me that if I have an x-intercept of 3 and a y-intercept of -5, that I have a point at 3, -5. Do I have a point at 3, -5? No. This is not a point. So you need to think about it visually. If you have an x-intercept of 3, what are the coordinates for that point? 3, 0. So you should write on your paper 3, 0. If you have a y-intercept at -5, what are the coordinates for that point? 0, -5. The best thing you can do to keep yourself from making a mistake is to write down those coordinates before you ever start, so you don't get confused and think that there's a point at 3, -5. I'm sorry, say it again. The line itself is the line that connects these 2 points. So there is no point at 3, -5. That would be way down here. Okay? It's telling you to write the equation of a line that has an x-intercept and a y-intercept of those points. So the line you're writing the equation for would go through those 2 points. Does that make sense? Okay, so we need to write the equation. So what do we need to know? What's the first thing we need to find? The slope. We need to find our slope. So to find the slope, you could graph it, or you could just use your slope formula. Slope formula, if we use these 2 coordinates, what's going to go on the top? And what is our y2 minus y1 in this case? Okay, so what would I actually write down here? Oops, my bad. I'll come back to it. Go ahead, Bailey, what would I write down? -5 minus 0. So I would write -5 minus 0. And then on the bottom, if I do -5 minus 0, what would go on the bottom? 0 minus 3. Okay, what is -5 minus 0? -5. 0 minus 3? -3. And what do we get when we have a negative divided by a negative? Positive. So my slope is positive 5/3. So N for M, we're going to put positive 5/3. Okay, and what does x1, y1 mean again? It's just a point that's on your line. We know for sure 2 points that are on our line. We have an x-intercept and we have a y-intercept. So at this point, you can pick whichever one you want to use. There's 2 possible answers. One answer would be to use the 3, 0. So let's plug in the 3, 0 and write our equation like that. What's going to go in for y1? 0. So we would have y minus 0 equals 5/3 parentheses x minus what? 3. That's if I use the 3, 0 point and plug it in. This would be my answer. Or you could use the other coordinate. So I'm going to use the 0, -5 and write another equation. They both would be acceptable answers and you only need one of them. So I would have y what? Plus, what did you say? Y plus 5 equals your slope of 5/3, parentheses, what would go in our parentheses? X minus 0. Okay, I want to make sure everybody's with me. That's plugging 0 in for x1, -5 in for y1, and then our slope, which we found, which was 5/3. Either one of these would be acceptable answers. If you distributed the 5/3 and added the 0, or distributed the 5/3 and subtracted the 5, you would get the same equation. You don't need to do that because it said point slope form. So you leave it in one or the other form. Questions? Okay, let's look at some graphing problems. Make sure you can graph. I'm going to skip this one. Let's go to this. Graph this line. Another very common mistake on the test is being able to graph the line correctly. What form is this in? Point slope. Y minus y1 equals m times x minus x1. Okay, so let's pick out the things we need. We need the slope. What's the slope according to this problem? -2. And then we need to know what is a point on our line, x1, y1. So be careful when you pick out your point. Remember, the formula already has a minus in it. So when you pick out your point, it should change your signs. Also be careful that you don't go from left to right. Your ordered pair should be x, comma, then y. So what should be our coordinate, our point? Okay, should be -4. We're over here with the x's first, because if this is a minus but it changes to a plus, then our x1 must have been -4. And then what is our y1? +3, because we already have a minus in the formula. So again, the way I remember is just switch the signs every time. When you pick out the point, switch the sign. When you plug in the point, it's going to switch the signs. Okay, then you do not have a graph. Sketch one really quickly. But remember, you're not going to do that on your homework. Before you leave, you're going to grab graph paper. To graph this, we will graph the point -4, +3. So always start with your point. If it's slope-intercept form, you'll start with your y-intercept. If it's not, then you'll start with just a point if it's point-slope form. And then where do we go from that point according to our slope? What does a slope of -2 tell me to do? Down to right 1. Okay, -2 is the same as -2 over 1. And when we say our slope, we want to be sure to include direction, so try not to use the words over. So we're going to go down to right 1. And then use a ruler, draw a nice straight line, put arrows on the ends. Is everybody with me that you have to change the sign when you pick out the point, and it's x then y. So you're kind of going at the end of your equation then back to the beginning of your equation. Okay, I'm going to throw up one more example that's not in your notes. I want to make sure you know how to graph this line. What if it was y equals 2/3 x plus 3? Where would we start? 3 where? On the y-axis. So this is slope-intercept form. We would start with 3 on the y-axis. And then what would we do? Say it again. We don't know what x is. We're just trying to use our slope and our y-intercept. So just like here, we picked out a point. We went from our point and used our slope down to right 1. Here, we have a specific point. It's the y-intercept. So we start on the y-axis at 3, and then we use our slope. What does our slope tell us to do? Careful. It's positive 2/3. So up to what? Right 3. So we go from our y-intercept, just like we went from our point, and we use our slope. Up to right 3. And then draw the line that goes through those 2 points. You guys remembering this from Algebra 1? Okay. All right. On your notes, quickly, the thing that we have not gotten to is what is it called whenever the lines are right on top of each other? So we talked about how if they have the same slope and the same y-intercept, then that makes them coinciding, right? We didn't use that word. Coinciding is what that means. You're going to have to memorize that. Coinciding. Same slope, same y-intercept, same exact line. If they have the same slope and the same y-intercept, you're going to put coinciding. If they have the same slope but different y-intercepts, we've already talked about, that means they're parallel. And if they're not the same line, they're not parallel, then they're going to intersect. They might be perpendicular if they have opposite reciprocal slopes, or if they just have different slopes that are not opposite reciprocals, we just call them intersecting. Okay? So, we still have 3 minutes. And because I'm not going to be here Wednesday, I need your full attention. Just a couple more minutes. I want us to look at this one example, okay? This one's easier because it's already y equals, y equals. You should easily be able to pick out the slopes and the y-intercepts, right? Is everybody with me there? Do these 2 lines have the same slope? No. That means they cannot be parallel. It also means they cannot be coinciding. To be parallel or coinciding, they have to have the same slope. If they have the same everything, they're coinciding. If they just have the same slope, they're parallel. So what would be the answer here? Intersecting. Do they have opposite reciprocal slopes? Careful. They have opposites, but are they flipped? No, so these are not perpendicular, just intersecting, okay? Let's look at one more. What would we have to do here? Notice this one is y equals mx plus b, but what's wrong with this one? What would we have to do before we could answer this question? Divide by 6, and everything would get divided by 6. So that we would have y equals reduce -1/3 x plus 2. You would have to get y by itself first. So use your algebra skills to solve for y and then compare your slopes. Do these 2 lines have the same slope? Yes, so they could be parallel or they could be coinciding, but they're not intersecting. Do they have the same y-intercept? No, so which one does that mean they are not? They're not coinciding, so what are they? Parallel. Okay, the only thing that should be left in your notes is a word problem. Is that correct? All right. I know that was a lot and it was rushed. Hold on before you go. Homework assignment is due when? Next Monday, but don't wait, guys. Start on it tonight while it's fresh on your mind. You will have time in class on Wednesday to work on it as well. And then don't forget you have the review to work on also. And I am here before school at 8 o'clock tomorrow and Thursday. You can request encore for Thursday. And you can call or text me anytime until 9 o'clock. After 9, won't guarantee you that I'll answer, but before 9, I will answer. Please make sure you get an assignment slip before you leave. You're free to go as soon as you have a blue slip. Thank you for being patient.